Okay, now we're going to give us the zeros. Oh, we're going to find some polynomial functions. He's in search of poly, I guess. So here we go. Suppose x equals negative 1/2, x equals 3, and x equals 3. How would I write a function? Well, first off, I could say x equals negative 1/2 could be x plus 1/2, or remember the Madagascar, move it, move it, move it, move it. We need to choose one. We can either choose that one or this one. Now, I'm going to be honest with you. I don't want to work fractions, so guess which one I'm choosing? I'm choosing the 2x plus 1. So what happens is this. I have a 2x plus 1. And remember inside liars? X minus, if it's positive 3, it'll be x minus 3. And I have it not once, but twice. So therefore, I just wrote an equation right there. Whoops. Can't kick the thing there. All right. Not trying to kick the habit of math. All right. Now then, but we need to multiply those out. If I FOIL this one, it would be x squared minus 6x plus 9. And then I have to multiply this one times this one, which the way I would do that is kind of like, think of it as 169 times 21. You would take the 1 times the 169, or 1 times each of those, which will give you this. And then you move over a spot, and you multiply the 2 times all of those, which will give you that. But then I line up the x's and the x squares and the other things. And then just like a regular problem that we did the old-fashioned way, like 169 times 21, you add the 2 together, and I end up with 2x cubed minus 11x squared plus 12x plus 9. Oh, this 2x cubed comes from 2x times x squared. 2x times negative 6x makes 12x squared, and 2x times 9 makes 18x. And then you add these together to make those. Negative 12, and that's a 1 plus 1 makes negative 11. And you can see the other numbers straight up and down. There's nothing to add to them. So that would be the answer to question problem A. What about B? Well, I have an x minus 3, remember inside liar, and then I have an x minus the quantity 2 plus the square root of 11, and I have an x minus the quantity 2 minus the square root of 11. Well, let's be real honest here. Let's kind of like flip the parentheses around. This negative, that means it's going to both those. So if I take that negative 1 distributive property times that, I get negative 2. And that times that makes it negative. And over here, the same thing's going to happen. That's still going to be negative 2, but this negative now became a positive. And what I want you to notice is this is kind of like a difference of squares. Remember, if you have a minus b times a plus b, it's equal to a squared minus b squared. Notice, if I let a be the x minus 2 and the b be the square root of 11, I have this quantity minus that one and that quantity plus that one. So when I FOIL them, I would have this quantity squared minus that quantity squared. Well, and I can FOIL x minus 2. That's x minus squared minus 4x plus 1. And the square root of 11 times the square root of 11 is a 11, which will be negative because I'm in front of here. And I can put the 4 minus 7 together and get negative 7. So I have this. Now I've got to do just what I did on the other problem. I'm going to take that x squared minus 4x minus 7 times x minus 3. First off, I do all of those numbers. 3 times 7 is going to be 21, positive. It's going to be positive 12x and a negative 3x squared. If I take negative 3 times each of those, that's what I get. Now I'm going to take x times each one of these, and I'll get a negative 7x, a negative 4x squared, and an x cubed. And I lined them up, the x's together, x squareds and x cubes. Now I'm going to add them together, and I get the equation to be x cubed minus 7x squared plus 5x plus 21. That's how you can find all the given zeros of a function. Now this would be one of the more complicated ones because of this right here. Most of your problems are going to be like this type here, very much just inside liar type stuff. And then simply multiply them out to get the final answer.